Hello, everyone. Good morning, good afternoon, good evening, wherever you are. Thank you for joining me today. My name is Deepak Singh, and I run the Containers, Linux, and High Performance Computing organizations at AWS. I also run the Amazon Open Source Program Office. I've been with AWS for over 13 years, focused on compute, and in that time, I've been really lucky to see the cloud evolve from provisioning virtual machines by the hour to where we are today, custom silicon, containers, and serverless technologies. This year, reInvent's a little bit different. Some of us are physically in Las Vegas, while others are recording our sessions so that we can offer a great virtual experience for you as well. This talk is one I look forward to every year. Like in years past, I'm going to talk about application modernization. But this year, I'm going to change gears just a little bit. And I'm going to focus on some of the outcomes that our customers look to achieve in their modernization journeys, including some of the key practices that they adopt to drive these outcomes, and very specifically the role that containers and container orchestration play to help them achieve these outcomes. This talk is going to stay at a relatively high level. I'll touch upon some of the recent innovations that we are doing in the world of containers, and I'll point you to sessions that you can go watch where you can get into greater depth, whether you're in person or tuning in remotely. Last year in my talk, I had quoted James Buck, and I said, "There is no magic, there is only awesome." The idea was that there are no silver bullets, and if you have great tools which you understand well, you can achieve great things. This year, I'm going to quote one of my favorite TV characters, Uncle Iroh from Avatar: The Last Airbender. Uncle Iroh was talking to his nephew, Prince Zuko. For those of you who've seen Avatar, which I have about 50 times, Prince Zuko was trying to get his honor back by trying to please his father, and he believed that he needed to do certain things to get that honor back. And what Uncle Iroh told him was that instead of trying to please somebody else, what he needed to do was look inside himself and understand what he needed to do. What was the outcome that he wanted to achieve that would make him successful? And I think we can all learn from that. Every organization is different. We are all in a different part of our journey. And if we really look towards the outcomes that we want to achieve, I think we can get there the right way and make our organization successful. I've had the great fortune of working with hundreds of customers over the last few years as they move to the cloud and adopt the cloud. There are some customers who are in the second or third evolution in the cloud over the last decade or so. And one of the key lessons I have learned from observing these customers is the ones who knew what outcomes they wanted to achieve at the particular stage that was relevant to them. Some of them could have just started in the garage, while others have become 1,000, 2,000, 3,000 person companies making billions of dollars. But understanding that destination usually leads to a more rewarding journey. Let's start with one of my favorite examples, which is the Vanguard Group. The Vanguard Group was an early adopter of serverless container technology. And to talk about their journey, I'd like to introduce William McEwen, Head of Cloud Compute from Vanguard.
Hello, everyone. My name is Bill McEwen, and I'm proud to be representing Vanguard today. Vanguard is a global asset manager with over 30 million investors. We employ 17,000 crew, and we have no physical branches, so technology has always been a key enabler for our business. Today, I'm looking forward to sharing with you some details on how we've leveraged Amazon ECS, Fargate, and Spot to fuel our technology modernization journey. In late 2015, we started to really think about the public cloud, not only to keep up with advancements in technology, but also to meet growth objectives of our business. Our migration to AWS started in 2016, and we hope to have 90% of our workloads running cloud native by 2024. To achieve that goal, we knew that we needed a compute environment that could empower thousands of developers operating in small and autonomous teams to deliver value faster. We knew we needed to protect our core assets and safeguard our clients, and we knew we needed to be cost efficient. To meet those objectives, we selected ECS Fargate using the Spot scheduler. As a result, we've seen improved speed and dexterity. Using ECS Fargate, we've gotten out of the business of infrastructure provisioning, even when our applications required substantial scale. With Fargate, much of the day-to-day operations required for maintenance and security is already baked into the product. These efficiencies have allowed us to achieve a 450% increase in platform utilization over the last 18 months alone. And our developers are now able to deliver new microservices in as little as 24 hours. And we've also seen increased cost efficiency. For example, we recently automated the use of Fargate Spot at scale across our environment, which decreased our enterprise-wide ECS charges by over 50%. And we did that during a period of substantial growth. Cost optimization is core to Vanguard's mission, and our platform teams are empowered to prioritize cost efficiency along with feature requests. The built-in cost transparency provided by ECS, as well as technologies like Spot, allow us to ensure an efficient spend as we move more of our portfolio to the cloud. And ultimately, that reinforces our business case of migrating to AWS. I'd like to close by saying thanks to the CTO team at Vanguard and all of the engineers that are helping to make our public cloud goals a reality. And thanks to AWS for the opportunity to share our story. Thank you.
Thank you, Bill, for joining us today and sharing Vanguard's transformational journey. Vanguard has increased the speed of application delivery, reduced their cost, all of this without compromising on the security and resilience of their applications. Given what they do, that was really important to them. That's just one story. There are many, many stories like this. Companies of different sizes in different stages of their modernization journey with a variety of needs based on their industries. They each have their own reasons. They each have their own business drivers for moving to the cloud and choosing to modernize. But there are three outcomes that tend to bubble up when we talk to our customers and as they look at what's been happening over the last few years. Speed and agility, security and operational resilience, and cost reduction. Let's talk about them one by one. I'll actually start with reducing cost. When people talk about cost, they typically mean the amount of money you're spending on operations, on infrastructure, on people. All of those are really, really important. But it's not just that cost that's super important. Those are critical components. But the thing I'll ask you to think about is how often have you had to delay a project because you didn't have the resources to get started? Or that the time it took to get everything together was just so long that it was not worth it, and you said, you know what, maybe some other time. I know I have been in those situations in the past before I came to AWS. I'm a physical chemist by training, and every chemical process has an activation energy. That is a cost that you pay for that process. And you have to basically pay that cost to get to the other side and have the reaction complete. In many ways, the cloud acts as a catalyst. It reduces that activation energy, that opportunity cost that you have. And it's a big component of how our customers look at the cloud. So, to give you an example, what does this mean? One of the biggest barriers to modernization is that customers do need to change their infrastructure and best practices. Some of our customers are doing the calculus that if they're able to reduce the cost to actually get started, to experiment and build applications, this is before they even do anything, they can move faster. A great example is you may be a company that's decided you're going to use Kubernetes, and you start looking at everything you need to do to be successful running a Kubernetes infrastructure, and you go, oops, too complicated. I'll keep doing what I'm doing. But if you adopt the cloud, a managed service like EKS, or managed Kubernetes service, you can move much faster. You no longer have to worry about managing a Kubernetes infrastructure because we are doing it for you. This is a simple example, but that is the outcome that is front and center for many of our large customers, to lower that activation barrier, to move faster and get going, so that over time, they're able to achieve the outcomes that they want to. Turns out, by doing that, you often end up spending less money, using less infrastructure, and doing it at an overall lower ROI. So you win on every dimension. A related outcome, and probably the one you hear about the most, definitely in the press, is speed and agility. Our customers want to respond to their customers. So this is after you've gotten going. You want to move quickly. The market conditions change. Guess what? We're in a pandemic. Everybody's market condition changed. We all had to move quickly. And the customers that were able to take advantage of the cloud and the capabilities that the cloud provides to adjust were the ones who did well. So people want to build quickly, iterate more quickly, make changes as they're needed. But to do so, what many find, especially those who are coming from a more traditional infrastructure approach or traditional way of building applications, is that most of their time is spent keeping the lights on. And one of the biggest advantages that they get with the cloud is that ratio essentially gets reversed. You're spending more time innovating, writing code that is actually important to your business, writing applications, and less time racking, stacking, putting things together. This has been a value prop for the cloud from the day it came about, and nothing has changed, even though we keep providing you more and more tooling as our customers get more sophisticated. At AWS, security and operational resilience are our top priorities. All push comes to shove, we will drop most things to make sure that we can keep you secure and that we can be operationally resilient. Our customers also think these are really important. They're customers who spent an inordinate amount of time addressing security concerns, dealing with regulatory and compliance issues, or just keeping their applications up because uptime is critical to their customers. The challenge is, as your infrastructure and applications get more complex, and this is especially true if you're building highly scalable, resilient applications, when you're modernizing, you are making that journey towards a little bit more complexity in how these applications are written compared to what it used to be. So the amount you have to think about security and how you think about availability goes up. One of the terms that I've heard come up quite often in the last few years is this term called shift left. And it took me a while to figure out what people meant when they said it. But essentially what they mean is that instead of security being bolted on at the end of writing an application, or where you throw it off to a security team or show it to them and they tell you, yes, you pass all, whatever rules we have, what if you could build things that are important to you from a security perspective into the infrastructure, into how your applications are built? And a lot of what we are trying to do is to enable that. And in many ways, the cloud does enable that. For example, you heard from Vanguard about some of the reasons they picked Fargate, like the isolation model. That is just a feature of Fargate. You no longer have to think about container isolation when you're building on Fargate. And it's a great way to think about shifting left. In the end, what it means is you're building your applications and you're not compromising on your security issues, on your regulatory compliance, on anything that you need to do to get your application into production. And it's another great example of how the cloud helps you achieve your outcomes. Werner Vogels, who is the CTO of Amazon.com, has said many times, we are in the pain management business. That's actually one of my favorite quotes, and partly because it's not set in stone. It evolves as we have evolved. It evolves as the applications that you're running evolve and how you choose to run them. Containers, container orchestration have become a big part of addressing the pain of modernizing infrastructure and building distributed applications. The threshold of pain that you're willing to endure changes. It depends on the maturity of your organization. It depends on your expertise and the requirements that you're trying to achieve. Our hope always is that we are able to find you the right solution to that pain. A great example of this is LogMeIn. As I mentioned earlier, a lot of companies choose EKS because they want to adopt Kubernetes, but there is inherent complexity in managing and running large-scale Kubernetes environments. And by moving to Amazon EKS, a company like LogMeIn is able to move quickly. They're able to scale to the needs of their real-time communication applications. They're able to handle the needs of a 10x spike in the amount of video usage that they have had since 2020. And they were able to achieve all of this. So they were able to get the scale. They're able to get the availability that they wanted without having to become experts at running Kubernetes by choosing a managed service like EKS. And the reason they picked it was simple. It has a great track record. It addresses the problems that they need to, reliability being a big one. And it integrates into all the other AWS services that they need to use, VPC, EC2 autoscaling, a variety of open source tools. If they'd done it themselves, they would have to figure all this out. EKS takes care of it for them. They're able to achieve their outcome, which for them is actually managing that scale without giving up on resilience. And that's a great place to be. Sometime over the next 3 to 4 years, some 500 million new applications are going to be built. Now, whether it's 300 million, 400 million, 500 million, it almost doesn't matter. The number of applications that are going to be built over the next few years is going to be more than the total number of applications built over the last 40. That's pretty impressive. And it's also daunting. It means that the activation energy, the cost of getting started, the cost of building these applications has to go down a lot. And the way people are achieving this and trying to get there is by modernizing how they build and run these applications. I have long said that without containers, people would have evolved how they run their applications. By adopting practices such as infrastructure as code, infrastructure automation, continuous delivery, deployment automation, observability, sort of the 5 key components of modern architecture. Containers and container orchestration definitely reduce the barrier to getting going and building these kinds of applications. But there were companies even before containers came along that were doing that. And I actually think that the world of containers learned from what some of these customers are trying to do and makes it a lot easier for people trying to modernize today to get going. So what about containers made them interesting? Containers are a small atomic portable unit. Much like shipping containers, they allow you to put anything you want into them. You can put in code, you can put in operating system packages, you can put in your dependencies. And just like a shipping container, those units can be put on different forms of transport. You can put them on your laptop, you can put them on an EC2 instance, you can run them on something more serverless, so like designed to run containers like Fargate. And in fact, today you can package up your functions and run them on Lambda. There's no surprise there are 1,700 ways of running containers on AWS because containers are just so useful. So containers are the best thing since sliced bread. They solve everything, including world hunger. There's always a catch. And the catch in the world of containers is the container is just one part of running an overall infrastructure and running your applications. You have to figure out how do you take something that you may have built on your laptop and deploy it to a very large-scale distributed infrastructure. And to do that, there are many ways, and many ways that have come up in the last few years. ECS was launched in 2015, was when the GA was, the preview was in reInvent in 2014. And at that time, when ECS came out, there was no way for customers to build and manage these large distributed applications. Most of them were doing it by hand. And that's complicated, and only a few people have the time to do it or care to do it. But at around the time that ECS came around, suddenly more options came about. So ECS came as a simple way for you to take a container and deploy it onto a fleet of virtual machines. Soon thereafter, as Kubernetes got more popular, we launched Amazon EKS, our managed Kubernetes service, which was very focused on helping customers address the biggest pain point of running Kubernetes, which is managing the Kubernetes control plane. EKS took that away from you. But increasingly, things like ECS and EKS are becoming foundational building blocks for more. What if all you want at the end is to run a web application or run an API? That's where something like AWS App Runner comes in, where you start with just code or a container image, and at the end, you just get a service endpoint. It makes life a lot simpler. It solves a lot of problems, and you don't need to know anything about the underlying infrastructure. Supporting all of these is AWS Fargate, a serverless compute option for containers. With Fargate, our goal was simple. I'm going to try and not get on my soapbox about clusters, but maybe I will. One of the things that didn't make sense at the time the containers started becoming very popular was the fact that they almost seemed regressive. You now had to think about containers and machines, and worse, clusters of machines. That is the equivalent of thinking about racking and stacking physical hardware when EC2 launched. You were no longer thinking about that, but we created these two things that you had to think about scaling and patching, etc. So how can you move to a world where you're just thinking at the level of an ECS task or a Kubernetes pod? That's where Fargate came in. You no longer had to worry about patching. All your operations were at the sort of container level. You didn't have to worry about figuring out how to scale your fleet, what instances to pick, how do you pack your instances onto those clusters. Those pain points all became ours. That is a pain that we set out to solve with Fargate. And it seems to have been super, super useful because we've been able to build all these experiences on top of that. ECS and EKS in the end are fundamental building blocks that we've continued to evolve. With ECS, we've added concepts like capacity providers, which take the idea that ECS started with, which is how can I launch a set of containers or services onto EC2 with these powerful scaling constructs, which could be on Fargate, which could be on EC2, which could be on an outpost, which is a physical piece of hardware that you can get from AWS and put in your own data center. And we've introduced concepts like Copilot, which help you get going much more quickly. With EKS, we've gone beyond managing the Kubernetes control plane to actually managing the nodes that your workloads are running on with managed node groups. Basically, the goal remains simple. Reuse your Kubernetes experience and expertise without having to worry about the mechanics of managing Kubernetes. And at the end of it, these foundational building blocks allow our customers to move quickly, build really powerful experiences. They reduce the cost of building and running applications. And most importantly, you can do so without compromising on your security and resilience. That's a trope you'll keep hearing from me because that is so important for so many of our customers. And by having such good foundational building blocks, not only do our customers get to build things, but AWS can innovate as well. You have services like AWS Batch, which are designed for a particular workload and user type that build on top of ECS. Batch used to run on ECS on EC2. Now it supports Fargate as well. It allows us to build services like SageMaker or Managed Grafana that underneath the hood might be running ECS and EKS, but you don't have to worry about it. You're doing machine learning. You are doing visualizing dashboards, which you do with Grafana. And this foundational services that we have built allow us to do a lot of innovation on top while addressing a lot of the pain that you have to go through when you're running your own infrastructure. Another lens that you can put on it is the shared responsibility model. For those of you who have been on AWS for any period of time, you've probably heard us talking about shared responsibility since day one. The idea is security and general operational stability of your applications are a shared responsibility between AWS and you, our customers. Shared responsibility is not the same thing across all AWS services. It looks a little bit different. And as we've added more services, the idea of what is shared has also evolved. In fact, some of our customers want AWS to be a little bit greedier and grab a greater share of their responsibility. This goes back to what I talked about cost earlier. By AWS taking on a greater share of the responsibility, that activation barrier, that activation energy that our customers have to cross does get reduced, and they can get going much more quickly. Let's dig in a little bit to understand what shared responsibility means. And we'll start with the OG compute service, EC2. EC2 was launched back in 2006, quite literally changed my life. And what we said with EC2 was that AWS was going to be responsible for the physical servers, everything running in the data center all the way up to the hypervisor. The guest operating system, the packages and applications running inside that operating system, making sure they were patched and safe was your responsibility. You were responsible for hooking up load balancers, figuring out scaling, how to do deployments, how do you get your changes pushed, et cetera. Now, over time, AWS has released services in every single one of these categories, and you can get going much more quickly. So even though the responsibility has not changed, the cost of the responsibility has lowered, but the choice remained with all of you. Then along came containers. Containers started decoupling the operating system from their applications within an EC2 instance, because you're still running these containers on EC2. You were bundling your language runtime, all the dependencies with the application, all inside the container image. And your operating system essentially became the shell which you are deploying all your applications into. That's great. It changes the responsibility a little bit. When ECS came along, customers were building their own orchestration. They were building all the management around it by themselves. And suddenly, that management layer was not your responsibility. It was our responsibility. And AWS was managing that control plane. But in the end, the EC2 instances were still there. You still had to worry about patching them. You still had to worry about connecting load balancers. The orchestrator made it a lot easier, but you still had to deal with a lot of that. You've heard my trope on Fargate, so I'll mention it again. Fargate changes the shared responsibility model. Suddenly, you no longer had to worry about patching instances. You no longer had to worry about scaling the underlying physical infrastructure, just scaling your containers. Your networking got a lot simpler because you didn't have 15 choices. You had just one choice, the VPC model, which is what Fargate uses. Essentially, AWS was taking on more of the responsibility of running a container infrastructure, which from your perspective means that you have to have much fewer people operating that infrastructure. Your security is in a much better place. And the benefits that Fargate provides have led to our customers adopt Fargate in droves. A good data point for that is over the first 3 quarters of this year, more than 65% of new ECS customers have chosen to run their applications on Fargate. And that's, I only think that number is going to go up over time just based on the trends that we are seeing and as we add more capabilities to Fargate. Cloud infrastructure is inherently flexible. You talked about the fact that containers by themselves don't make an application. You have to build your code. You have to scale your applications. You have to connect your applications to a load balancer. Even if you're running on ECS and Fargate, those are all things that you need to do. What if we could flatten all of that and reduce the complexity of running these decisions and of helping you run that infrastructure? And that's where AWS Copilot comes in. AWS Copilot is essentially a domain-specific language, or a DSL, on top of provisioning ECS applications, most used commonly on Fargate, because as I just said earlier, just for the first 3 quarters of this year, more than 65% of new applications are running on ECS Fargate. What Copilot does, it makes you think about your application, not the infrastructure. It gives you simple commands to initialize your pipelines, to create and develop your applications, to release them, and to operate and monitor them. Underneath the hood, everything is built as CDK templates, as CloudFormation templates, and you can go and open the kimono and see everything, but you don't have to. If you just want to build and run, Copilot allows you to do that. But you can do more. Earlier this year, we released AWS App Runner. App Runner is a new service that provides a very simplified experience for running web applications and API servers. So, with Copilot, you could define your application, you could deploy it, you can build it, but you could also go and look underneath and make changes. What if none of that mattered? The only resource App Runner returns to you is a service endpoint. Everything under the hood becomes our responsibility. The container orchestration, the runtime, the scaling. If you look at the shared responsibility model again, the amount, even more than Fargate, because in Fargate you still have to think about what load balancer you're using, what build system you're using. With App Runner, none of that matters. So what you get is much increased productivity because the activation barrier for you to get going is much lower. Once you launch your applications, you can move much more quickly because you can react to scale because you don't have to think about scaling anymore. We think about it for you. Security is built in. Deployment safety is built in. And by the way, if you have your own CI/CD pipeline that you wanted to hook App Runner into, we allow you to do that. You don't have to use the way App Runner does things. We also allow you to plug in to what you have. And then you're only paying while you're serving requests. So all of those reasons are reasons why our customers are starting to use App Runner as well, for those of you who want to build web applications or web services APIs. So in the end, our goal is to meet you at whatever threshold of pain you want to use. You have a set of services that you can choose as your entry point. If you have adopted Kubernetes, with Amazon EKS, you have a managed Kubernetes service that's going to make your life a lot easier. That's what you should use. If you just want to run containers on AWS, pick ECS, most likely with Fargate, because it's going to reduce so much of the pain that you would have faced about scaling and running containers. And if all you're doing is building a web app, you want to deploy a web API, start with App Runner. There are different trade-offs for each choice, but they're all available to you. And that's a good place to be. One of the things I often hear from our customers is, containers, great. Container orchestration, great. AWS has all these cool services to help me run my containers. But AWS does a lot of other interesting things. There's a lot of innovation happening across the board. How can we benefit from it? And one of the, I used to be on EC2 for a long time. I used to be the product manager for EC2 instances. So not surprisingly, one of the areas that I'm super excited about is Graviton. The Graviton processor is a processor that has been developed at AWS. It gives you up to 40% better performance compared to similar Intel-based instances, and it's 20% cheaper. So in the end, you're getting 2 to 3 times better performance per watt. And you've already heard stories of customers adopting Graviton in spades, moving quickly. And this is especially true for people running containers. Containers, especially a container registry, support multi-architecture images. So with the same container image, if it's a multi-arch one, you can get going on ECS and EKS without really doing much, without making many changes. So you've heard the story of Snap. Snap moved a significant chunk of their infrastructure over to Graviton very quickly and achieved great price performance. And you can go and hear previous talks that they've given on this subject. But I'm not going to talk about Snap in detail today. The customer I'm going to talk about is ParkMobile. So ParkMobile is a service. It's a mobile app that allows you to do things like find parking spots, et cetera, using, in real time, using your phone. ParkMobile was able to move to Graviton-based instances using EKS. So they moved to the M6G instance. And what they found was they were able to get the same application performance with 50% fewer instances. So they are saving cost. In this case, the money cost of it. And the overall cost of running their applications went down 46%. So they're able to reduce their footprint. They're able to get essentially half their costs compared to what they were running earlier or using EKS. And that transition was super simple because using containers, the transition from a x86 architecture to an ARM architecture is relatively easy. And if you can do it, if your application compiles to ARM, I would strongly encourage all of you to make that change. All right, ECS, EKS on EC2, running on Graviton 2 processors, all fine and dandy. You can make all the change you want. But what about Fargate? I spent a whole bunch of time just now talking about how amazing Fargate is. And if you're on Fargate, you were out of luck. Not anymore. As of now, if you're a Fargate customer, you can run on Graviton 2 instances too. You get the same price performance benefits, so up to 40% better price performance, 20% lower cost compared to an x86-based Fargate, similarly sized Fargate setup. And for a broad spectrum of workloads, you'll get significant cost savings. And in fact, if you are in Las Vegas, you should catch up with the Fargate product team. They're doing a Chalk Talk, and they'll dive deep into a bunch of new Fargate innovations, including all the new support for Graviton 2. There are other cool innovations that happen in AWS that help you reduce cost. Another one is Spot instances. From the very early days of Spot, our customers have been able to get up to 90% cost savings by running workloads that can be interrupted on Spot instances. The hardest part about Spot is managing all these interruptions and what do you do when an interruption happens. But container orchestration, again, makes it a lot easier to manage these interruptions because the container orchestrator knows what to do when a change in the system happens. So not surprisingly, Spot instances are represented pretty significantly among our container customers. And even for them, one of the key requirements was, does Fargate support Spot instances? So a great example of a customer that has taken advantage of containers and Spot is Edmunds. For those of you who don't know Edmunds, Edmunds is a website that you'll use if you've ever looked for a car. You've probably checked out edmunds.com. And they were able to get significant performance and infrastructure cost improvements by moving their 68 applications, 30 million monthly requests over to Spot instances. There is a mixture of EC2 and Spot, and they're able to reduce their cost by 30% compared to what they would using EC2 on demand. And today, they're running 80% of their customer-facing applications on Fargate Spot. And over time, they'll probably move all of them over, at least all that makes sense. And the sort of flip side of the architectural changes that they made as they move towards running these sort of interrupt-tolerant applications using Fargate and Spot was they increased their availability to 5 nines, which is pretty cool. So, I think there's many benefits that you get from containers and container orchestration, and you combine them with the overall innovation in the cloud, it's a pretty compelling story and delivers really good outcomes for our customers. So we've talked a lot about cost. We've talked a lot about activation barriers. We've talked a lot about how the cloud help, and what we are doing with containers helps you shift left and move quickly. Let's talk about what our customers are building. Our customers are building a wide variety of applications with containers. These could include mobile and web applications, which is what many of you expect. Lots of backend web services. People are doing edge applications using containers. Increasingly, a lot of data processing is being done on containers. I see a lot of gaming companies starting to adopt containers at scale. Sometimes all customers do is use something like App2Container, which is an application that we have that looks at your .NET or Java code and containerizes it. And then they basically shove it into a container and move it over to the cloud. Others are building what are called shared services platforms. I mentioned Snap a little bit earlier. Snap has built this shared platform that a team builds with all the requirements for a modern application architecture, and then they make that available to the rest of the developers. That's a very common use case for containers. And last but not the least is machine learning. If you haven't been paying attention, machine learning is a big deal. And over the last few years, the amount of machine learning that's been going on in the world seems to have exploded. There's companies of all sizes adopting machine learning as part of their day-to-day operations. Number of startups as well, and they all are running in containers, or at least it seems to me like that to me. A great example is a name that you probably know well, which is iRobot, which is a consumer electronics company. I presume many of you have the little robots running around your house. So they needed to do some machine learning to build models for their devices. And what they chose to do was running Kubeflow on Amazon EKS. So this abstracts away the infrastructure complexity from their ML scientists and engineers. So they could experiment and iterate quickly. They could run it on AWS. And because it's Kubeflow and Kubernetes, they could run it on their own data centers as well. So that's just an example of a company that's adopted machine learning in containers. And there's hundreds more across all these categories. So what are the reasons all these companies are adopting containers? We've talked about outcomes, but there's a bunch of other things that come to mind as well. One is they're all reducing risk. They're getting uniformity across all their environments because containers provide this consistent runtime environment, this consistent packaging environment that works on your laptop and works in the cloud. They're getting significant operational efficiency either by building good density by running containers on EC2, or by adopting things like Fargate, where they can get significantly more structured. They're being able to move much more quickly and enabling their developers. And they're able to adjust to changes much faster. These are all, as I said earlier, these are all things they could do without containers. But containers have made that process and adoption a lot easier and reduce the barriers. Having said that, intent is great. Everyone intends to modernize. Execution can be a challenge. So how does an organization enable developers without compromising on business requirements, like compliance? I've worked with organizations that have talked about modernizing for a long time. They've even adopted containers. But they really haven't been able to get things into production because they may not have the skill set, or the amount of organizational change that needs to happen to move to this new mindset is just daunting. So we started thinking about how we could take that pain away and reduce that activation barrier. And that's where AWS Proton comes in. So today's development teams are building applications made up of dozens or hundreds of individual components. You could call them microservices. I like calling them services, and hopefully they're decoupled. In many cases, these services are meant to be independent and modular so that one team can build and operate a service and can iterate and innovate independently of another team. It's a lesson that we've learned at Amazon many, many years ago. You heard us talk about it a lot. But to achieve that success, we had to organize in a particular way, and we had to develop a lot of tooling. So as our customers are adopting these modern practices, they're facing some of the same challenges that we faced 15 years ago. Some customers, I mentioned Snap, have built these shared services platforms to abstract away this infrastructure challenges to enable the developers. But not every customer is capable of managing all this tooling or even building it, nor do they have the time. So all this cool stuff I said about container orchestration, does it mean that it doesn't matter? That's not true. You've seen the success a lot of customers have had. But there are customers for whom it is a challenge, and that's where AWS Proton comes in, to lower the activation barrier for them. So what Proton is designed to do is take all these modern best practices. You heard me mention infrastructure as code, deployment automation, orchestration, observability earlier. And what it does is it allows a small team to take best practices and encapsulate them in these patterns and templates. And they approve these templates, and they publish them to Proton. It provides a single interface for delivering those applications, which their developers can then pick up the ones that they need and then run them. The central team then has the ability to know what's running. They have the ability to monitor changes. If the developers want something new or they want to ask for a change, there's mechanisms to do that. And you get this feedback loop that allows even a company which may not have all the skill set in management or does not want to invest in it to be able to do that. And we are seeing a significant amount of interest from enterprises in particular that want to leverage Proton to bring these best practices to their organizations and enable their application development teams. This is when I take a little bit of a sidebar into a buzzword, which is GitOps. Many of you may have heard of the term. You may even be familiar with it. But I think most of you have sort of just heard it and haven't dug in. And if you try and Google the term, you'll be inundated with so many definitions you won't know where to start. So I'm going to give you one more. I'll give you hours. So GitOps is different from previous deployment practices. The name would imply that it's some combination of Git, infrastructure as code, and CI/CD. That is true, but there's more to it. With GitOps, you can define an entire environment's configuration in a source code repo or a collection of repo using infrastructure and code. You can and should be able to completely recreate your environment just for that config repo using immutable deployments, which means you never update your existing environment. You create a new one, and you toss the old one away. And the environment can be any boundary that you choose. It could be an account. It could be a Kubernetes cluster. It could be a Kubernetes namespace. It could be a CloudFormation stack. There's many ways to skin that cat. But the key is that you are able to recreate the entire environment just from that repository using immutable deployments. The other critical component of GitOps is that you need an engine that does automatic reconciliation on all of these environments. Means it's continuously driving the actual state of the system. And when there's a deviation from that state, it knows to go back to the repo and rebuild your environment, basically recreate that environment to make sure it matches what's supposed to be in the repo. A great example of this is, by the way, this happens a lot. If someone manually deletes a production load balancer or changes a setting, your automatic reconciliation should kick in, recreate the load balancer, or change the settings to match what's supposed to be in the config repo. Adopting GitOps is a journey. And here's what we've seen our customers do to be successful, because I think people are still trying to figure it out. One, you have to adopt infrastructure as code. You don't have an option. So use something like CloudFormation, CDK, Terraform, Pulumi, Kubernetes templates. And you have to use immutable infrastructure deployments. So always build a new Army, an Amazon machine image, before deploying. This is where containers are great, because if you take ECS, for example, an ECS task definition by default, the only way you can do it is immutable. You make a change, there's a new definition. Or you can use something like Lambda. Along with that, you need to use continuous delivery. So you have to adopt CI/CD to automatically deploy these code and infrastructure changes, no manual changes. You have to treat your config as code and put it in a repo. I'm sure every single one of you has had an outage because somebody fat-fingered a config change because you weren't treating it as code. So once you do that, you need to make sure that you're versioning all these changes, and you're able to use all the same tools that you use to manage your code to manage your config. And your repos and everything feeds into this, and you can recreate changes. The last But not the least thing that you have to do is you have to figure out what your drift detection and automatic reconciliation engine is. The Kubernetes community has done a great job with tools like Flux that allow you to go ahead and rebuild your environments, do this continuous reconciliation, et cetera. So all of these things, if you do them together, is what makes adopting GitOps successful. And not, people are still early in their journeys, but the ones who have been successful have done so by doing that. So why should you care? GitOps enforces certain excellent practices for you. It enforces continuous delivery, version control, immutable artifacts, immutable deployments, and automation. You have a declarative configuration and reconciliation, which allows you to basically be where you need to be. It maintains drift, so you don't end up in Frankenstein states that you shouldn't be in. It allows your platform and application and all your teams to have a single shared set of code review tools and other things that you need to do your earlier development. And perhaps most importantly, it allows you to model deployments that match your organizational boundaries. And the last bit is very important because it makes GitOps a very good fit for Proton. So one of the things that we want to do and are doing with Proton is to bring in GitOps capabilities and GitOps practices to Proton. So there's a bunch of new features we've launched for Proton since we launched in GA earlier this summer. But there's a couple now that are in preview that bring into account some of these GitOps style practices to Proton. The first one is that Proton is able to render Terraform modules and make a pull request to the configuration repository. So if you're using Proton to help with the management of Terraform-based infrastructure, you can now make pull requests to a customer repo. And if you have your automation set up right, which you should for Terraform, everything will just work, and it'll work with your automation without changes. I guess the second sort of key part of this is you can now use Terraform with Proton. The second feature that's now we have also launched, and this is new, is template sync. So you can create a Proton template, sync it with the Git repo of your choice, and when changes are committed to the repo, Proton now detects that change and automatically creates new versions of your environment based on that repo. It's something I just talked about. So this drastically shortens your test cycle for new templates. It's been a super popular customer request. And you want to find out more, there's a whole session, Contour 2, where they talk about Proton and some of these new capabilities. In the end, I'm super excited with where this community is going and some of the practices that we are building together. And this is all new to even some of us. But it clearly solves customer problems, and our goal is to help you reduce the pain and complexity of adopting these patterns. You've probably heard every single person you've talked to at AWS say security and operational excellence are job zero. Now, I think I've said earlier today that when push comes to shove, to make sure that things stay secure and that we are resilient, we will drop everything and do that. But the other part of this is something else that I talked about earlier, which is shifting left. You heard Vanguard talk about this. You heard me talk about this earlier. We want you to use Fargate, not just because it's serverless or something, and my big rant about clusters, but with Fargate, we do more, you do less. You don't have to patch. We are responsible for patching the underlying infrastructure. You just have to worry about your applications. You do not have to worry about task multi-tenancy or how you would keep your applications safe from each other. Fargate follows a strict isolation model. You never share a kernel across two tasks or two pods. There's no privilege mode for containers. You have ephemeral storage that's always encrypted. These are just things that we built in. This is something that we take care of for you, and you don't have to worry about. Another area where we sort of built security into our offering is BottleRocket. So for those of you who don't know what BottleRocket is, it's an operating system, a container host operating system that we built to host and run containers on any infrastructure. It's an open source project. But we made security a critical capability of BottleRocket. It provides SE Linux in enforcing mode. It has an immutable root file system that's backed by DM Verity. There are no shells or interpreters installed, so there's no SSH by default. You can install it. We would recommend that you don't do it. There's automatic security updates. So there's many capabilities built into BottleRocket that help you be more secure. Amazon ECR is our container registry, and your container image is often the heart of your overall infrastructure. It's the heart of any container workload in AWS, whether you're running it with ECS, whether you're running it with EKS, whether you're running it on EC2 or Fargate. And by the way, if you're using Lambda, as the container image is essentially the standard packaging format that people are using. Customers want to be assured that the software used in the containers is safe. Everybody cares about supply chain these days, especially if it's coming from third-party publishers. So we launched ECR with container, we added container scanning as a free feature to ECR a while ago. We are now launching our enhanced scanning for ECR with Amazon Inspector. This solves 3 needs that we hear from our customers. 1, scan not just other layers, but the programming language packages, so Java and Python, etc. 2, scan images continuously in case new vulnerabilities are found, not just at the time that you push the image. And 3, you integrate the scan findings with all the existing security tools that you have, like Security Hub, for example. So you are able to provide scanning more broadly across the entire security, share those findings, and be able to take action. Second, and this is also new, is many of our customers want to use public images, and they want to use trusted content. Content is super important in public registries like ECR Public. So we actually worked with our friends at Docker, and where a lot of software providers provide official images on Docker Hub. So we've worked with them to take the trusted content for images, like let's say Ubuntu, and provide them through ECR as a partnership with Docker. So this should allow you to have more trust in the public images that you're using. And the third one is adoption of open standards. So I talked about image scanning. You can also sign your images. That's super important. We are working with the broader open source community on an update to the Notary spec, which is an image signing spec. And the image signing spec essentially allows you to sign an image and deploy it, but we're going to do it by enhancing the Notary spec. It's something that we've been actively involved with, and the plan is that all the signing features that you'll have in the container space on AWS will be built on that spec, and you'll see us do a lot more next year. Talking of community and open source, I just talked about Notary v2, and we really care about Notary as something that we want to invest in because it's good for the community, so we decided to work with them. There are other projects like Kubernetes that we are actively involved with because it makes sense given how much work we do in that area. But the project I wanted to talk about a little bit was Containerd. A few weeks ago, I learned that AWS was the second largest contributor to Containerd, at least at the snapshot that we took at that time. And there's a reason for that. Containerd underlies Fargate. Containerd can be used with EKS. At some point, it'll be used with ECS as well. It's super important for us to make sure that Containerd is high quality, that we make it better, not just on AWS, but in general. So that's a great example of how we get involved with the broader community. There's another set of projects that are open source that are things that we started, things like Firecracker, things like BottleRocket, that we will open source. There's a project called Carpenter, which is a great example of how we think about it, which is we wanted, some of our customers had challenges with Kubernetes provisioning and scaling. And the existing built-in autoscaler for Kubernetes on AWS, it works, but doesn't work exactly for their workload types. So we started a new open source project called Carpenter that will work with any Kubernetes, whether you're running it on AWS, outside AWS, doesn't matter. But it brings in some of the best practices we know about provisioning and scaling applications for that particular application type and for that particular use case that we have. And we're going to work with the broader community and our customers to make sure that they can all be successful. That's a great example of how we think about open source within the container organization. Carpenter came out of a need for performance. And quite honestly, performance is something that I care about deeply, and many of us here at AWS do as well. Because I'm pretty sure if I come and ask you, do you want your applications to run slowly? None of you will say yes. You always want them to run faster. And that's where performance investments come in. So Carpenter is a great example. There's a session on Carpenter at reInvent, Con 210. Another great example of performance improvements is the pull-through cache that we've implemented with ECR, where if you have images, say, in your private repo on-prem, you can use ECR as a pull-through cache to get access to those images quickly on AWS. There's a session on that also, Con 211. You heard me talk about Graviton. Another good example is the GPU support we added to ECS Anywhere. It also speaks through to all the interest in machine learning. But there are things that you may not notice right off the bat until you actually stress out the system, is the things like the fact that we increased the throughput that ECS supports by 5 times this year, or we made better clock drift time sync capabilities available to you in Fargate. These are all performance investments that we make. Many of them are underneath the hood, and you may never notice them until you realize that your app is just running faster. But it's a critical part of how we think about making your lives easier and helping you move more quickly. When you're thinking about containers, one of the first things that you want to think about is, where are you running? Over time, what we found is our customers want to run containers in different places. You started off in infrastructure on AWS. This is where ECS and EKS started. And people were able to achieve a ton of success on them. But some people wanted to run in their own data centers for whatever reason. For those people, AWS launched Outposts. You can run AWS infrastructure on the telco edge with AWS Wavelength. Or we can have sort of these metro areas of infrastructure with AWS local zones that are close to your customers, and you might want to serve them with lower latency. You can use ECS and EKS on all of these and have from the day they launched. But we also have customers that have their own hardware, whether it's hardware that they want to use, or they're in some colo somewhere, or that hardware is in an edge location, like a point of sale system or in a fast food restaurant. For those customers, we launched ECS Anywhere and EKS Anywhere, with the idea being that you should be able to run your infrastructure wherever you want. You decide where you want to run them. We're going to try and give you a common experience. So let me talk about these for a little bit. So what is EKS Anywhere? So EKS A, as we call it, is a new deployment option for EKS. So it allows you to create and operate Kubernetes clusters on your own infrastructure, on infrastructure that you manage, but fully supported by AWS. It builds on our Kubernetes distribution, EKSD, which is an open source distribution of Kubernetes. It provides you a set of operational tools that bring the best practices that we have running EKS, a sort of similar model. And then you can basically run your own Kubernetes clusters using the same operational model as EKS. And you can come talk to us if there are issues. We patch it, we maintain, we manage it, we push updates, and so on. Optionally, you can connect your EKS Anywhere clusters to the Kubernetes, to the EKS console using the connector that we recently launched as well. Now, by the way, it doesn't even have to be an EKS Anywhere cluster. It could be any Kubernetes cluster. But the general idea is that we want to give you visibility and tooling that allows you to run a consistent Kubernetes experience wherever you want to run. ECS Anywhere is a little different. It's essentially a feature of ECS. It builds upon the same sort of simple operational and deployment model that ECS has. It's the same API experience. All you have to do is install the ECS and SSM agents on whatever infrastructure you want to. Could even be a Raspberry Pi sitting in your living room. And point it to the ECS control plane in your favorite region. And we'll be able to deploy containers on that infrastructure. One of the differences is that you always have to have a connection into an AWS region. Well, you can lose connectivity for up to 12 hours, and then we rotate credentials, and well, then bad things can happen. But as long as you maintain that connectivity using the same ECS control plane, you can connect to an Outpost, a Wavelength, your own infrastructure, doesn't matter. If you want to go from deploying on a Raspberry Pi to deploying on a Wavelength location, all you have to do is a new deployment. So doesn't matter whether you're a Kubernetes customer or an ECS customer, we have ways to help you run your containers wherever you are. So I'm going to close with this. It's what we talked about all afternoon. You choose your destiny by choosing your abstraction. You can choose to turn all the knobs that you want, use Kubernetes, use EKS. You have everything available to you in that vast Kubernetes environment, all the tooling, all the open source projects. You can do whatever you want. You can choose to just say, nah, I just want to run containers, don't have to worry about patching and scaling anything, and you can run with ECS and Fargate using Copilot. Or you could say, all I want to do is run a web service, and I'm going to use App Runner. Regardless of whatever abstraction you choose, we have a solution for you, and you can pick based on your needs. You can choose where to run your containers, whether it's in an AWS region, in an outpost, or wavelength, local zones, your own hardware, doesn't matter. We have you covered. And very importantly, you can start thinking about security integrated into your infrastructure and applications. It's no longer an afterthought. You still have to work with a security team to make sure that you're doing the right things, but you have all the capabilities from us to take some of the core pain points of security and not have to think about them because you've built them into the way that services are built. So to bring all of this together, once you start off understanding what you want to achieve, how you want to achieve it, and what your goals are, you can then pick your destiny. You can decide which abstraction you want to choose. You can decide where you want to run your containers. And I think this shouldn't even be an option. Shift left, adopt tools that give you more security, better resilience, without slowing you down. I've talked a lot about some of the innovations that we've done, the reasons people pick AWS Container Services, what they do with them at a fairly high level. If you want to go in a level or two more into depth, there's a number of sessions, both in person in Las Vegas or in virtually, that you can dig into to learn about basically everything I've talked about today and then some. Thank you very much for your time. It's been great to talk to you again about application modernization. I look forward to doing it again next year.